Howdy everybody in YouTube land. Now I'm going to get into the more technical details of this console. Basically, what we have here is a 4x8 keypad, key matrix, and actually I think I have a circuit board laying around. Let me see if I can find it. Here we go. At least this will give you a better idea of the insides of the keypad. Basically, what we're going to do is take a quick look at this thing and get a further detail. Anyway, there's the Atmega 128. Then, of course, we have an 18 megahertz crystal, which is overclocked from the maximum 16. We have the Dallas real-time chip, the ADM 483 transceiver, and at one time that was actually a 1200 baud powerline modem. Unfortunately, the biggest problems with these is up here. Right there used to sit a Coilcraft branded powerline coupling coil, and it's adjustable like an IF transformer. Unfortunately, that coil goes bad and they're no longer available. Another fault with this keypad was that chip there, which was a TL071 op amp, would fail for some reason or another. But anyway, then we have our rectifier, our battery, and all that fun stuff. And then we have the microprocessor reset generator to ensure that there's a stable reset on power up. There's the in-circuit programming header and all that stuff. And then, oh, the clock start-stop switch, which is right here, plugs in right there. So now to flip the keypad over, that's the 7805. The 7905 would go next to it, but the modem's not being used, so it's not in there. Then there's the key matrix, which is your basic tech switches. So that is a rough diagram of the keypad. So that's the old technology keypad, which I have to use right now. But in my Eagle folder is the new one. See if I can pull it up. To wait for Eagle to launch. The hard drive is just now waking up. I have it set for the hard drive to go to sleep. So, okay, here we go. Now, move this flashlight out of the way. There's the new keypad. There's something a little bit different with this keypad. Basically, this time I put fuses and transient voltage suppressors on the communication lines. And I also added 232 support along with 485 support. And then, if you look closely, you can see the 5 registers. Yes, I embedded LED driver registers on the keypad. I'll get to that in a minute. But and then there's the key fob, those Chinese 4-button key fobs with momentary contact. That's going to be the official start-stop the clock, and be able to increment score. So you're going to have your scorekeeper at the console, but then the official can be out on the field or in the basketball stadium or wherever and be able to start and stop the clock from any point. 433 megahertz tone-based, generator. But there's the I2 LCD connector, and then there's the power supply. I chose to use the MIC 4680 switch mode DC-DC converter. I'm trying to get away with those stupid linear regulators. But here is the keypad. Of course, there's the new inscription. And of course, I have to have my mad scientist, because I am a mad scientist, phone number of the company. So, but anyway, let me discuss the layout a little bit more. The inner layer cutout is around the horn relay, because the 120 volts is going to be passing through there. So of course I decided to cut out the second, third layers just in case something would go wrong. Then of course there's the pad mat, or the copper area fill for the MIC 4680, which is surface mount, and it can either be ran off the 24 volt load or the 12 volt AC load. Then over here is a PNP transistor based load switch. I haven't prototyped this circuit to see if it's going to work as expected. Okay, in the schematic, that's the actual load switch. If you take careful consideration, there's the 24 volts in, comes around into the load switch. This is a pull up that keeps the transistor shut off, 24 volts, and then that's a pull down. The reason why I have this resistor here is because most MOSFETs have a maximum gate voltage of 20 volts in either direction based on if it's N channel or P channel. In this case it's a P channel. So that means from here to here, drain to source can't be any greater than 24 volts. So this gets pulled to ground, we're at 24 volts. So we're going to exceed the gate voltage limit a little bit. But that's why I have this resistor here, so hopefully we don't blow the transistor. But yeah, that's the load switch to the register chip, so when the clock goes into standby, it cuts the power off on the LEDs. Of course, there's the output enable, but you know, I just want to make double sure. And of course, we have the keypad, and then there's the Atmega 128 microprocessor, the locations for the transceivers, the coil for the 82, or no, I think it's 68 microhenry inductor. Then the Schottky diode and cutouts and shit like that. And then there's the fuses and transient voltage suppressor for the communication lines. And then there's the proper layout of the Dallas 1307. That's the button key fob header pin. And then just above that is the LCD and then the programming pin. But yeah, there's the load switch, and then there's the main filter capacitor, which goes right there. With any luck at all, this guy should work perfect. Okay? So, this is not save. No, I don't want to save. I don't want to open the, let's see. Actually, let's open the driver. There's my project. That's my project. I was able to actually vector in the logo of the company. I just do my rat's nest. Got a copper fill for the 24 volts on top to drive the LEDs, because the inner layer contains the 5 volts and the ground, so I had to stick my 24 volts on the top. I didn't have a choice. Then we have a serial in-out slave for the Cat5 RJ45s, same suppressors, Wi-Fi Ethernet header, and then dip switches to set the scoreboard address and the slave address. And then we have the same switching regulator setup, except there's 3 of them now: 5 volts, 3.3 volts, and 12 volts. And I have LED headers, so I can solder in surface mount LEDs for diagnostic indications. And then up here we have our TO220 load switch. And since there's a lot more drivers, I opted for a TO220. I'm thinking about changing the package and make it lay flat, so the heatsink will sit in like that instead of vertically. But I'll figure that out later. And then there's a transient voltage suppressor on the 24 volt. Then there's the filter cap and the pull down and all that fun stuff, and you know, main power supply circuits, a ground tie point for external circuitry that I might have to do, and then my Max 232, and yeah. Anyway, and then there's the schematic. All of those registers, whole crap load of them. You just imagine this took a while to make. There's dip switches, the processor, the voltage regulators, all that fun stuff. But anyway, let's go ahead and close Eagle now. Oh, I don't want to save. But anyway, back to the point of this discussion. more technical detail about the keypad. So I was programming the keypad and finally got things figured out on the menu system and, you know, all that fun stuff, but I still haven't figured out the RS485. I don't know what's going on with that, but that's the wire to the 485 transceiver that's going to the back of the computer, which is unhooked. Because what I did was I tapped off my TTL 232 into the SparkFun breakout board. So what we're going to do is, first things first, we're going to turn the keypad off. So it's going to shut off. And then compile the program. And then we're going to bootload it. Uploading. It takes 20% of the 28K flash memory. So it should be done. Yep, it is. So what we're going to do now is we're going to turn on the console. No game in progress. We can now operate our menu system. New game, set brightness, LCD contrast. Well, let's do the contrast. So I can adjust the contrast to the LCD. Enter. Contrast set. Menu. System setup. Set brightness, LCD, date and time, show time of day, horn mode, board address, and then back over to new game. So let's just do date and time for a second. Enter. I want to do the date. That's the current date. So I can clear that out of there. So I don't want to set that. And then, whoops, too far. And then the time. That's the current time. And I'm not going to enter it into time because I don't need to. So, and that's pretty much it in a nutshell. So what we're going to do is we're going to do game time. Start a new game, yes. Set game time. We'll do a time of 15 minutes and 30 seconds. Enter. The quarter is 1. Start the clock. And there she goes. Works great. And I can stop the clock. Everything's good. And then of course, whoops, wrong button. Then of course I can go into menu and then do show time of day. Enter. Yes. So now it's in time of day mode, even though the game is running in the background. So the game's running in the background. You just don't know that it is. So I can implement the scores up, down, all that crap. And then I can hit game time again, and there's my scores where I just set them. So everything seems to be working. We'll go ahead and power down, powering off. That's it. Thank you for watching. See you next time.